Hi, and welcome. In this webinar dedicated to 5G devices, we will present the state of 5G, an overview of 5G device value chain, the different markets for 5G devices, and ultimately what are some of the challenges engineers face in developing and producing the right device for the right market and the right time to market. We will link these challenges with the practical view on our solution and get a glimpse on how our design approach of our CMX platform on both hardware and software can help engineers get faster time to results, which would result in fast time to market. My name is Gotze, and I'm here with my colleague Tim.
Hi everybody, my name is Tim, and Gotze, I'm very excited to be here with you today.
Thank you, Tim. So let's get started. So the state of the 5G global ecosystem in this Q3 snapshot, it's an overview basically of chipset manufacturers. So at the moment, what we're seeing is basically that we have around 82 commercial chipset devices available on the market, out of which 44 are millimeter wave, and more importantly, 68 are standalone. We have 6 announced chipsets out of this 82 commercial devices. What is important to note is that out of this announced 6 chipsets, we have around 4 millimeter wave devices, which all are dedicated to the fixed wireless access use case. On the device side, we have a big number of devices, which is around 1,500 devices, more or less, out of which commercialized are 1,267 and announced we have 254. So what is important to note is definitely that the millimeter wave features are still in the announced form, and we have enough devices that are millimeter wave commercialized. But more importantly, what we see is a growing number of the fixed wireless access device ecosystem growing in both sub-6 and millimeter wave. When it comes to the deployment and availability of the networks for these 5G features, what we see is that currently we have around 500 operators that are either investing or have deployed 5G networks. So commercial at the moment are around 226 networks, out of which, and this is very important, 26 have implemented what we call the real 5G with the standalone function. And out of those, around 59 have commercialized the millimeter wave in one form or the other. But again, more importantly, we see that one of the most promising use cases and picking up is the 5G fixed wireless access, where around 90 operators have launched fixed wireless access commercial services. But on the investing side, we see both on deploying or fixed wireless access are being heavily invested. And interesting to note that the 5G private, which we see a lot in the news, we have already around 193 networks being either invested in, trialed in, or being deployed. So it's something that we monitor and looking forward to support this ecosystem. When it comes to the actual connections on 5G, we see, yes, a growing trend of these connections. Just in Q3, we see already we are at a point of 690 million connections, and this has just a growing effect. So that's currently today what we call the state of the 5G device chipsets and operators. But what we call is also it's the state of the user and how a state of a 5G user looks today. So what you will see is that today a current 5G user uses 40 gigabytes of data every month. So this is what we see already by tier 1 reports in operators across North America and also in Asia. And basically, 5G user streams 2 times more radio in comparison to a 4G user, spends 1.5 times more time on social media, and plays 3 times more mobile games. And of course, all of this enhances or complements the enhanced mobile broadband use case, which is actually today the most common 5G use case, and it is what is being monetized the most. So when we're talking about the future of services, we see a few services that will come in near future and will shape, let's say, the 5G monetization. One of them definitely being fixed wireless access. And here we see more and more operators, especially investing in these services, where consumers can enjoy ultra-fast broadband, and they can also enjoy this across all their devices, on their mobile devices in both home and out of their homes. Another future service that we see is the industrial IoT, which really it's about fueling what is called the smart factory or industry 4.0. Here we see a number of services around it and devices, starting from 5G routers for the industry that enable the connectivity, and also peripheral devices that are enabled with some of the IoTs, and specifically the REDCap or the NR Lite, which is coming. Third service that we see is the NTN or non-terrestrial network. And this service is really to bring connectivity to areas where there is no service available today. So it's really to mitigate this coverage gap. And one of the few use cases that we see today, it's really about this SOS or mission critical messaging. But later on in the future, we can expose some of the other use cases coming in this presentation. And of course, there is this extended reality services that we see some of the biggest companies addressing some of these challenges and working on the services and devices. And I think a lot will come in this space of this extended reality, because the services and the idea of it are endless. So this is the state of the users and the services. Just to give a perspective, I will also introduce here the 5G device value chain. So what do we talk and what do we mean in this value chain when we talk about a 5G device? So that means a device starts basically by making the actual chips that are produced at the chip vendors. And here, of course, we have different testing use cases that are starting in the R&D and in production phase of those chip vendors. And in the R&D phase already, we have things like RF testing, signaling testing, application testing, OTA testing, and pre-conformance testing. Of course, once the chip is being built, it is given to the device manufacturers that are producing the actual device. And they also basically do the testing in a similar manner like the chip vendors, but probably in a reduced manner and effort. And of course, one of the main testing challenge for them is production or yielding or scaling device production and making sure they have the right system to test and to ensure the product quality when it's being produced. And after the device manufacturers in the ecosystem to enable the devices, we have device houses that are, or test houses that are actually certifying the device according to 3GPP standards. And they really test this we call conformance testing or conformance approval. And they do also carrier acceptance testing or over-the-air testing. And the last is the operator, who would do also conformance approval of these devices, carrier acceptance, and also put this device in operation. And of course, we have the different types of devices. Speaking about the engineering profiles of today and who are the actual testing engineers, which are an essential part of the device ecosystem. Just because they do the testing, of course, they need best-in-class instruments. So we have them spanning from R&D, validation and conformance and manufacturing, and their different profiles. So of course, starting from a job profile like RF engineer tester, he would be thinking of and working with characterization of transceiver optimization and debugging. Of course, signaling engineer will do chipset verification and test plans around layer 1 and layer 4. And of course, investigating and debugging on the modem. And application engineers will validate the whole IP stack, whether it's TCP/IP for throughput or IMS for voice services. And of course, we have the conformance engineers, which are testing according to 3GPP and carrier specs. And then the production testers, as I mentioned, testing for high yield of devices and etc. What you see below is our mapping to the different products. And this is what I want to show you, that of course we span with our solution portfolio from signal generators and analyzer in the early forms of R&D, and later on spanning to more signaling tester, OTA solutions with chambers, and then in our conformance system, enabling the whole value chain. But what you see here across this whole value chain is one product, which is the CMX500. So basically, this is a product that support the whole value chain. Tim, what is so special about the CMX500 that we see it supporting the whole value chain?
Yeah, thanks, Gotze, for giving us the overview of the current state of the 5G and also the user personas. Well, the CMX500 is the device when it comes to 5G signaling testing. And we have it here. I want to show it to you now. We will first take a look on the hardware part, and then we will take a look on the software part. Okay, let's take a deeper look on the hardware design of the CMX500. The CMX500 has a modular and scalable design. That means all these slots are very flexible. In this case, we have a configuration with 2 RF boards and 2 IF boards. The RF boards are for LTE and FR1 and goes up to 8 GHz. The IF units are for FR2 and the range is 24 to 50 GHz. With this setup, we are ready to do end-to-end IP performance up to 20 gigabits per second. The CMX also provides an extensive IP and application test feature set on board. Now we want to take a look on the software part. So here we are in the home screen of the GUI of the CMX500. The CMX500 provides a web-based GUI, and we call it CM Squares. With CM Squares, we cover all the mentioned user personas and unify it in one user-centric approach. CM Squares is one software platform that unifies RF non-signaling, signaling, application, conformance or preconformance, and carrier acceptance testing. The tight integration of software and hardware enables robustness of the platform and addresses the user's challenges. Let's take a look on that now. As the name already says, the software is structured in squares. In the home screen, you can see, for example, some shortcuts to applications, like a message analyzer to see what's going on in a message, or an automation tool like the sequencer we will talk about later, but also the use cases. So here we have different kind of use cases like max throughput testing or also IP analysis. Let's take a look into the workspaces. So the workspace is basically structured in several parts. On the left side, you have always the settings, what you want to see in your squares. So for example, here I selected the network and the barrow and flow monitor. And on the right side, the corresponding configuration is available. So for example, if we want to change some settings in the honor cell, I just click in the honor cell, and here we can see all the settings which are possible to change. It is also possible to change the window sizes, to move boxes from one side to another, and do more configuration, whatever you want to see based on your use case. Now you saw how you can configure your workspace in an intuitive way, but what are the requirements of a 5G device? Gotze, can you tell us something about that?
Yeah, of course. Thank you, Tim, for this great presentation. So yeah, today's 5G device requirements in terms of the market, what we see basically is that, of course, a device have to have the availability of different bands and tiers in the bands, specifically in the spectrum, low, mid, and millimeter wave. So basically the ability of the device to have multiple bands across the different layers is what enables a good device for, let's say, enhanced mobile broadband market, and the number of these bands, so it can become a global device. Of course, the other aspect of the requirements is to have speed and capacity. So we see today basically a lot of aggregation is happening in order to increase the speed of the end user. And this can happen in different scenarios, either ENDC carrier aggregation or we have NR dual carrier aggregation. The other aspect is the massive MIMO, where now we're seeing a trend of moving basically from 2x2 to 4x4. The other aspect is definitely on the device requirements are the actual 5G enhancements. And here we have three, let's say, pillars: battery saving features, 3GPP mainstream release features, and in this case is release 16, what is, let's say, current on the market, and of course, spectral efficiency features. On the release 16 features, 5G standalone is of course the most predominant, the SRS antenna switching, the MIMO enhancement, the wake-up signal, and more importantly, in sub 6, we see the move from 4 carriers to 5 component carriers. From millimeter wave, we see already a trend moving to 10 component carriers, and basically even getting speeds from 7.9 gigs to 10 gigs per second. And of course, moving from ENDC carrier aggregation to dual carrier, NR dual carrier aggregation. And of course, at the end, we see the support for voice and various services and applications. And here, the move basically on EPS fallback to support VoNR basically, either natively or a fallback from 5G to VoLTE. we see the different release 16 positioning features, and of course, the introduction of the network slicing, and all of that needs to be encompassed into the device. And just to show the audience what we have today, if you see now, this is just from one example of an operator that working with his Spectrum asset, what are the different carrier combinations that he owns and he needs to test. And this is just NSA example of different type of combinations. You see there are more than 220 combinations. And of course, in a standalone mode, also, we're talking about more than 400 combinations just for one carrier, testing across all his assets, making sure that all that availability exists on the device so that users can get the great experience. So what does this mean for the engineers and the testers across the whole value chain? So basically, if we look at the 3GPP specs, we're talking about circa around 4,000 test combinations of all these carrier aggregation bands that are available in the standards. So this is certainly challenging in the industry, and we will need to optimize the time to results. So I would like to ask Tim what type of a solution we provide for the industry and the engineers to solve this challenge.
Yeah, actually, Gotze, you're totally right. All the different carrier aggregation combinations are a big challenge when it comes to testing. However, there is nothing to worry here. Rohde & Schwarz offers the tool which makes testing faster and easier. But before we will talk about the band combination challenge Gotze just pointed out, I would like to give a quick introduction about cable routing configuration on the CMX500. Using cable routing is easier to manage the different connections to the UE, which ultimately saves engineering's time. Cable routing on the CMX500 is very easy, as I already mentioned, and we call it connection selection. With connection selection, we follow a DUT-centric routing approach. So the idea behind that is that the customer can create DUT profiles and perform tests based on the saved profiles. These profiles contain supported bands or DUT connectors. And internal routing makes sure that the DUT will work for all the use cases you can perform with the CMX500. And of course, there is no recabling necessary. So now we know how easy it is to cable and route a UE with the CMX500. Let's take a look on automation. So here we are back on the home screen of CM Squares, where we host the CM Sequencer application. It allows the user to easily create a sequence by adding blocks in a drag and drop manner sequentially. Reverting back to the challenge of testing, the ever-increasing band combinations, we have carefully designed and implemented the band shuffler feature. Here is an example how the band shuffler functionality is realized in CM Sequencer. So here we are back on a home screen of CM Squares. The sequencer can be reached by clicking on the sequencer button under the applications category. In the sequencer square, you can configure different kind of things you want to see. For example, the sequencer editor or the recent test runs, or also if you want to see the test report in the full extent, you can also enable that to see that. Here we just preloaded the functionality, what we were already talking about, the band shuffler functionality. So let me show you how actually the drag and drop works here. So you can say, I want to add a function block. And in this case, we just want to add, for example, an LTE cell setup. We can just say LTE, configure LTE, and just drag it into the editor field. And here you can already see how the corresponding sequencer configuration window opened on the right. So CM Sequencer just realized we clicked on a configure LTE cell and provides us the corresponding configuration parameter. The output of the sequencer script looks like that. So here we have an HTML file, which comes as an output. And here you can see we read, in this case, the cell configuration from a CSV file. It is also possible, in addition to the CSV file, that we read the UE capabilities to perform the shuffler functionality in the sequencer. So the result of the CM sequencer is basically one final report with all the band combinations over all measurements you performed. So the shuffler functionality provides one script with which you can test any number of band combinations the device supports and get one test report which summarizes the results of all the band combinations. As we can see, the CMX500 is capable of solving known challenges when it comes to 5G testing. Back to Gotze to tell us more about fixed wireless access.
Yeah, thank you, Tim. That's great that we have solved that challenge. So yeah, moving forward, I will be speaking about 5G fixed wireless access as a market. So currently what we're seeing is that fixed wireless access makes fixed broadband an attractive or a competitive offering among all the other services, as shown on this slide borrowed by GSMA Intelligence, where you can see how 5G fixed wireless access fits perfectly next to fiber to the home or to the building with speeds from 1 to 10 gigabits per second. So really the time to deployment or time to service is what makes this service unique and attractive for operators and as well as for users. But looking a little bit deeper, the positioning basically there is targeting mainly the users in the underserved markets, the markets that are out of fiber coverage, or the markets that at the moment have DSL coverage. A certain analysis made by GSM Intelligence shows that the TCO for a 10-year TCO in comparison to fiber to the home, we see that in rural, suburban, and urban area, we see that the most cost savings are done in the rural area and in the suburban area, and then followed in the urban area. However, when it comes to strategy with all this NTN and fiber and fixed wireless access, a lot are being asked, what's the strategy? So what right now it's seen on the market, really the strategy is that operators go with fiber where it is viable, then they move to fixed wireless access where it is also viable, and then LEO or NTN is the last resort to provide fixed wireless access capability. And this is how this opportunity bucket of fixed broadband or basically spills across the different buckets of opportunity. Just to put things in perspective, if we see an example of Germany and certain coverage from an operator in Germany, you will see on the left side, this is the DSL coverage that an operators would have. And then in the middle, you see the fiber to the home coverage, and then you see the actual 5G coverage. So it is clear from this standpoint of view, if you want to have ubiquitous service or universal service with speeds that are going above 1 gigabits per second, definitely fixed or even speeds between 100 megabits and 1 gigabit per second, it is where 5G can solve this problem. So that's something to take into consideration, basically for operators where they're swapping the current DSL lines either for fiber, or more intuitively or faster it comes with the 5G fixed wireless access. When we look into estimation of the market and the CPEs, we borrow multiple analytics and charts. So what you see here is basically the number of the different 5G connections coming from the Ericsson Mobility Report. Then this is interpolated with some cost analysis done by Del Oro Group and the ABI Research Group by the number of vendors that will be present on the market in the different years. But in general, what we're seeing today that the fixed wireless access CPE devices have doubled from last year. We're at around 8 million 5G fixed wireless device shipments already. And this whole opportunity, if you see already in year 22, yields of around 6 billion of opportunity as a value of the device shipments, both 4G and 5G. So definitely it is a growing market for both device makers and the whole ecosystem for 5G devices. Already in the ecosystem, what is tracked by GSM Mobile, we see already quite a number of ecosystem enabled, like chipset manufacturers, different module vendors, and also device makers. And what is important to note is that the testing challenges and requirements basically vary. And you can say that the testing challenges from the chipset manufacturer are the most complex one, and then they basically decline all the way down when it comes to the device manufacturers. So this is we need to take into consideration when designing our solutions to have the right, let's say, the right feature that is needed to be tested. Here is an example of a device family for fixed wireless access by 2 vendors. We just took it from the GSA catalog. So you see it's a mix between outdoor and indoor units. Basically, the outdoor CP is kind of, or the antenna itself that it's put out on the roof of the house. And this can be either in a sub 6 gigahertz or FR2, FR1 or FR2. And also we have the capability in the same mode for indoor devices. When it comes to the test requirements for fixed wireless access devices, of course, they're very similar to the enhanced mobile broadband and smartphones. However, they differ in certain aspects. Definitely the end-to-end max throughput in download and upload is a need in this case. So max throughput testing is definitely something to observe. The ability to effectively do NSA and SA attach. More importantly, what we're coming is 1024 QAM that is to be enabled on the chipsets, because these are fixed, let's say, locations between transmitter and receiver or base station and CPE, which might allow for a bigger modulation, for a higher modulation, enhanced throughput. Definitely the stability and robustness of the device, latency, firmware versionings, and etc. And of course, then the generic RF parametric, operator acceptance, and OTA types of solutions. More importantly, there is also the need to test the power consumption of these devices, for example, in non-standalone and standalone mode, but also the thermal status. Some of the solutions that we have enabled for testing a fixed wireless access device are definitely the CMX500, the CMQ500, the NGM200, the Contest software, and the CM Squares software. But moving forward, basically, I would like to ask Tim once more, because throughput is an actual, let's say, thing that it's needed to be tested robustly, but more importantly, in a speedy manner by engineers. What type of solution does the CMX500 offers to the engineers to test throughput more efficiently?
Yeah, you're totally right. Throughput testing in fixed wireless access is a big challenge. But of course, we have a solution here. The CMX500 is the perfect platform to perform the end-to-end throughput testing, both with LTE and 5G. And for that, we provide a tool, or basically 2 tools. The one is called Throughput Wizard, and the other one is called IP-Tune. So what are these tools actually? So the Throughput Wizard is a wizard to help you to set up your network and your workspace. So we take care of that. You don't have to do that. We will do that for you. We just need some minor inputs like, are you an FR1? Are you an FR2? What is your band? And this kind of stuff. And we take care of the rest. And the result of that is you have a very nice configured CM Squares overview where you see all the relevant values and all the graphs which are relevant for throughput testing. The IP-Tune on the other side helps you to actually tune your device. So it can happen that you have a UE, you don't know what the capabilities of this UE are, but we help you to really push the maximum of the throughput by tuning it. So the problem to overcome, of course, is we have a UE with unclear capabilities. Yeah? And the feature is that we have a step-by-step qualification of the current channel of the UDP and TCP throughput. And this is happening by doing an end-to-end traffic measurement from the client to the server. And the testing of this is, of course, also supported by the shuffler, which we introduced before. So now I want to show you how that actually looks. So here we are back on our home screen of CM Squares. As I already mentioned, with the CMX500, we want to actually provide a very easy way to address different kind of applications and also use cases. The Max Throughput Wizard is one of these use cases and is so also provided on the home screen under use cases. So when we open the Max Throughput Wizard, it actually goes through 4 steps. So in the first step, the user have to set up the network. So we have to give the information, do we just have NR? Do we have LTE? Do we have both? And in the cell configuration, we have to set up which bands are we using. And then in the third setup, it is possible to already enable some of the throughput optimizations, like the DMRS optimization or also the mixed slot activation. The result of this is a very nice overview of the most important information you need when it comes to max throughput testing. We have, of course, the downlink throughput and the uplink throughput, and we have it both for NR and for LTE, depends on whatever you want to see. So now, when you measure the throughput, the question is it the really maximum throughput I can reach with this device? And to ensure that you really tune your device in the best way, we also provide a tool, what I already mentioned, and we call it IP-Tune. And the IP-Tune is basically for really, you can use it if you really don't know any of the capabilities, what it can actually do. And when you perform the IP-Tune, at the end, you get a result, what has been tuned. And after actually the tuning, we also do a remeasurement to really ensure, okay, this was our first measurement, we tuned, and this is the result now after the tuning. So with the Max Throughput Wizard and the IP-Tune, we provide two tools which helps you to first configure your workspace for the Max Throughput testing and measurement. And in the second step, we provide you the tool IP-Tune, which helps you to actually tune your signal to the maximum throughput. Gotze, back to you.
Oh, thank you, Tim. Interesting. So another topic basically that deals with throughput testing in devices definitely is the power saving features. And how do we test against those, but not only power saving, but also how do we test in terms of battery drainage. So we see that this is an example of ITU. On the left side, a chart that talks about the emission trajectories of the ICT operators and what they need to commit to in the Green Future Networks initiative. So here you see that fixed network operators, mobile network operators, data center, they need to reduce basically their emissions, and ultimately one of the things they need to reduce is also the power consumption. So there is a whole initiative going right now in the industry about these Green Future Networks that we're trying to optimize how the networks are run, where we save power, but not only the networks, which are bigger portion, we also need to make sure that we're saving power on the device side. And that's not the only thing. We need to make sure that the device also have this battery saving feature, which is also important for the user experience. So as power consumption, I said, is critical in 5G, and consumers expect longer battery life, we would need a solution across phone variables and also for the fixed wireless access CPEs. So I would like to hand over to Tim to tell us more about really how we support these solutions.
Yeah, you're absolutely right, Gotze. I mean, power consumption is one of the most important things on portable UEs nowadays, and it becomes more and more important. Let's take a look on some of the UE saving enhancements in release 15 and release 16. So for example, here we have DRX and bandwidth path switching on a release 15. And the future will be like wake up signal, cross-slot scheduling, RRM measurement relaxation, and also UE assistance information. And we also have some MIMO layer adaptation per bandwidth pass and also S-cell dormancy. Gotze already mentioned that we have a solution here. So what battery life measurements we can actually do here. So to perform some battery life measurements, we have a super simple setup, which is the CMX500 in combination with the NGM200. So the cabling is very easy. You just connect actually the power supply with the CMX500 via LAN. And from the power supply, you connect your battery to your UE. And from the UE, you connect just the RF signal to the CMX500. So this is all done by us. As you can see, the setup is very, very easy. So now we want to take a look how this is implemented in CM Squares. Okay, so as I already mentioned, for the power consumption testing, we also have a solution which is also implemented in the sequencer. The sequencer we have already seen before when it comes to the bench shuffler functionality, but now we are talking about battery life testing. So we can open the sequencer again, and here I already preloaded a script which actually performs the max throughput testing in combination with the power consumption. So this is actually very interesting because depending on how much power the UE is basically using or needs, we can see that the max throughput is also changing over the time. So when I take a look here on the script, we have the basic stuff like the network setup, activating cell and so on. And then we have this blocks here, which says start power consumption monitor. And as we know, the configuration of one of the blocks is always on the right side in CM squares. And here you can set up your connection, for example, to your power supply we were just talking about, the NGM200. And we take over of the whole connection control. So there is nothing you have to do, basically. We just have to know what is the IP address of the device. And the rest is all handled by the CMX500. So now let's take a quick look on an example measurement report of this power consumption testing. So here we can see we have all the configurations we saw also in the blocks. We have the scheduling information, for example, and we can also see, okay, here the LTE cell is activated, here the NR cell is activated. And then the very important part here comes when we do the actually power consumption results. So here we just measured the actual voltage and the current and the power of the UE. And of course, if you want, you can also set up some limits for lower and higher. And at the end, everything is easily visible in one measurement report. Back to you, Götze, again.
Thank you, Tim. That's very good that we have all these solutions for battery life measurements and power consumption testing, and all well integrated in the CMX. Very nice. Okay, moving forward with our presentation. 5G device expansion with REDCap. REDCap is definitely something that, or reduced capability, is introduced in release 17. And this is basically the idea of this feature is what we will see on the device side is really the proliferation or the expansion of devices in 5G across different use cases. But where does really REDCap sits in terms of fit when we compare it to what we have so far in IoT and what we have so far in terms of enhanced mobile broadband. So if we chart this on a chart where we have device performance and versus device complexity, what we see basically the highest performance devices, like with the case of enhanced mobile broadband and URLLC, taking the highest of performance and complexity, and ultimately with cost. Keep in mind the bubble, and the size of the bubble represents the cost of these devices on this chart. And then on the lower end, what we have is really the lowest in complexity and delay tolerance, which is really the eMTC and narrowband IoT type of devices, which is really low-end wearables, sensors, low-end sensors, as well as different type of utility meters and etc. Where REDCap really fills in the gap, it's in between, where we have the need for lower complexity and power. And here we have a few major use cases. One is really surveillance cameras, another one being high-end wearables, and the third one being really high-end industrial sensors. And of course, this can, of course, complement logistics and other use cases as well. So moving forward, in terms of cost reduction, etc., really what REDCap fills in is also the price of a REDCap device is estimated to be 4 to 5 times less than an enhanced mobile broadband type of a device. What we see across the system, that definitely it is a confirmed priority across whole 5G ecosystem, starting from device vendor, operators, and etc. So it is, as I said, a part of 3GPP release 17. What is important to note is that it has reduced complexity and cost, and really this is by targeting the lower throughput end, like 150 megabits per second in download and 50 megabits per second in upload. It has 64 QAM, 1 antenna for uplink, 2 antennas for downlink. It has battery saving and heat dissipation features. It has 1 component carrier, etc., etc. So in terms of market, what we're seeing right now, there are a few studies done by Huawei and others. What we see is that definitely REDCap is something that will take off on the market, and definitely we will need testing solutions for it. What I'm interested to know is from Tim again, how do we support REDCap, or do we have any plan to support REDCap on the CMX500 platform?
Yeah, of course, good. So we take the REDCap topic very serious. We know it's a very important topic. And we also know that there is a huge demand from our customers coming regarding that topic. So our first step when it comes to REDCap support with the CMX500 is basically in the first step, we want to check the UE for actually REDCap capabilities. And then in the next step, we want to set up the cells based on the REDCap capabilities. And this gives us the possibility to test actually the cell selection criteria for the REDCap devices. And with release 16, the power saving capabilities of the CMX500, we are already able to address the REDCap requirements in terms of battery life testing. So here we are on a really, really good path in order to address all these requirements which are coming in the future. And in a second step, we are addressing all the advanced features when it comes to REDCaps. So if you guys are interested in REDCap testing, please get in touch with us, and we are very happy to provide you some more information. Back to you, Gotze.
Yeah, thank you. Again, great to hear that actually we have a solution or let's say a roadmap in mind about this feature, really helping the 5G ecosystem proliferate more and more devices. Our next topic of today and the last topic is basically talking about 5G NTN. It's a big topic at the industry at the moment, and we see this use case already getting some traction. So what is it really about? It is really about non-terrestrial networking. If you see this chart, we have a terrestrial network, which is, let's say, in a 50-meter distance, usually from a user to the base station in a usage scenario. And then you see how the non-terrestrial network basically complements the terrestrial network. So if a user goes out of coverage on a terrestrial network, we have the two different satellite types like LEO and GEO with the different distances and covering the different type of use cases. So currently we see space operators build a satellite RAN networks. We see that they are deploying a 4G and 5G core networks. And basically how they enable the business case so far, we see that they're getting an MCC MNC codes, and in order to enable the business case, they're doing a roaming peering relationship with the terrestrial operators. So this is what we see, how they enable out of coverage, patchy coverage, and roaming scenarios, the different telcos that would manage the customer relationship. So the 5G NTN has addressable revenue of around 35 billion worldwide by 2035. This is few estimates, one of them from GSMA Intelligence, and there are others from Analysis Mason, etc. So really what is important to note is that there are two aspects of NTN. One is 5G NTN NR, and the other one is 5G NTN IoT. The 5G NTN NR basically has, let's say, use cases like direct link to smartphone for mission critical and low data services. We see here use cases such as disaster recovery, emergency services, small data when out of coverage, financial services and transaction payments. And we see that this feature is all about predominantly getting on a LEO satellites or constellation in a LEO altitude. And of course, this is latency and throughput more hungry when compared to a 5G NTN IoT use case, where we have, again, a diverse set of use cases, which is higher resolution of data points in asset trackings, ubiquitous drone connectivity, boat position information, wearable connectivity, and etc. And certain estimates say that 8% of the IoT market is already addressable by the NTN IoT use case. Having said that, what we're seeing with this technology is that really it covers few gaps. One of them, of course, being the coverage gap, and the other one, of course, having on the IoT side, ultimately something that expands on land, sea, and air, which is, I would say, the killer use case for certain IoT use cases. This is just an example to show what we have today in the NTN IoT industry as a support in standardization. So you see on these slides what are the supporting members from a standardization point of view, and you already see this mixture of convergence between telco operator and the different satellite operators and satellite vendors. So what I'm trying to say here is that the industry is heavily working to support NTN as a feature, and this is not something that if it will happen, it's about when it will happen. And we see already the early the early implementations of NTN in, let's say, in the forms of iPhone, but we're waiting for the standardized versions of this, which are coming later on. So what are some of the device challenges in NTN? Definitely, this has its own challenges. So one is the propagation losses that are because of distance and in the different absorptions due to the atmosphere. The other one is the Doppler shift, especially in the LEO case. We are having a problem with the Doppler shift on the UE side that needs to be compensated for. And this is one of the main challenges to obtain a proper link. Then we have, of course, the large delays and how to compensate for this, and also the cell movement. So in this case, for the first time, we really have a moving cell rather than a stationary cell. And in some cases, of course, the UE moves and the cell moves. And this is also challenging for the device maker. So with this topic, I would like to close today's webinar, and I hope you gained some valuable insights, and more importantly, you had fun as much as we did. So before I close the webinar officially, I would like to say my big thank you to Tim. Tim, it was a pleasure, and thank you for your help. Thank you, everyone.